So this video is all about simplifying fractions when they involve variables. So with this lesson, we assume that you are already comfortable with simplifying fractions when they involve just numbers. We'll go through a quick review of what that means and what that's like, and then we're just going to jump right into simplifying fractions when variables are involved in either the numerator or the denominator or both. So like I said, let's get started with just what we can in quotes call regular fractions, and those are ones that don't have any variables in the numerator or denominator, so it's something like 12/15. And one of the things we can do with fractions to simplify is just try to find out what types of primes they have in common. Here 12 and 15 both share 3, so we have to be very careful with notation, and that's we're dividing that 3 out from the numerator and the denominator to end up with 4/5. If we have a fraction that's a little bit bigger, perhaps, or rather has bigger numbers, maybe we have 24 and 32. Then we have one of two ways that we can go through this. We can either divide out primes one by one. Both 24 and 32 are divisible by 2, which becomes 12/16. Those are both divisible by 2, which becomes 6/8. And then 6 and 8 are both divisible by 2 also, which becomes 3/4. Alternatively, we can do that same thing, or rather take that same fraction, 24 30 seconds, and divide out the greatest common factor of the numerator and denominator, and that gives us also 3/4. So many different ways that we can simplify fractions. Now let's take a look at a fraction with variables and see if we can follow any of these same kinds of strategies to simplify that. Well, the first thing we can notice with this fraction, 4x squared over 9x, is that there are no common primes, no common number primes that we can look at. 4 is just 2 times 2, and 9 is 3 times 3, so there is no number that is shared as a factor by 4 and 9, so we can't take anything out there. But we have some variables involved here also. In the numerator, we have 2 x's. We're not sure what x the variable actually stands for. We just know that there is some number there that is squared, and in the denominator we have 1. Well, whatever x turns out to be, if x is 3, it's 3 in the numerator and denominator. If x is 5, it's 5 in the numerator and denominator. If x is 13 and 4/10, it's 13 and 4/10 in the numerator and 13 and 4/10 in the denominator. So, just like a prime, we can cancel some of the common variables from the numerator and the denominator. Both have an x in them, so we can take out this x from the denominator and cancel an x from the numerator. Now, in the denominator, we can just get rid of those x's to end up with 9. But in the numerator, we have 2 x's to start off with, so we're going to take away one of them and end up with 4x. So let's look at that one more way, where we actually take those variables and write them out as what the exponents mean, and it'll make it a little bit easier to see. So we have 9x in the denominator. We have 4x squared, and x squared means x times x. So we can say 4x times x over 9x. Here we can see that there is an x in the numerator and the denominator, and whatever it is, x divided by x is just 1. So those two variables cancel out, and we're left with 4x over 9. Any way that you want to write it or think about it is totally fine. But here, because there was nothing we could do to simplify the numbers, all we had to do is take away a common variable from the numerator and the denominator. Go ahead and pause the video and see what you can do with this one. If you don't have any ideas, just play around with it for a minute or two and see what you can do. Come back when you're ready to look at way that we can simplify it, and then we'll go through the process of simplifying fractions with variables, and then we'll go through 6 practice problems at the end. So here we have 2 things we can cancel. We have the variables and the numbers. Let's start with the numbers, because that's the thing that's most familiar with us. Between a 6 and an 8, we can simplify by 2. which gives us 3, and then the y to the 4th is still there. And it's about to write 8 again, but that's not the case. 8 divided by 2 is 4, and then the y to the 6th is still there too. So the numbers now are canceled. Now we can cancel the variables. The denominator has 6 y's, where the numerator has 4 y's. Now 6 is greater than 4, so we can cancel all 4 y's from the numerator with 4 of them from the denominator. If we take 4 out from the denominator, we're left with 2. So in the numerator we have 3 y's left, and in the we just have 3 left, and in the denominator we have a 4, as well as a y squared. So our simplified fraction is 3 over 4y squared. And that brings us to what the actual process for simplifying fractions with variables is, which is very much like what we did here. To simplify a fraction with variables, we can do either of these in any order that we want, but first we would simplify the numbers because that's something that is very familiar to us, and then whatever variables remain, if there is something we can cancel from the numerator and denominator, we do it. So go ahead, pause the video, and work on these 2 practice problems here. There are 3 pages like this. When you're ready to go through the answers, come back, we'll go through them and move on to the next page. So for this first one here, the numbers are as simple as they can get. So we have a 9 in the numerator and a 4 in the denominator. And now, as far as the a's are concerned, we have 3 a's in the numerator, 2 a's in the denominator. I'm just going to rewrite them here. And so we can cancel a common 2 a's, because whatever they are, they're the same thing, from the numerator and denominator, and we're just left with an 1a in the numerator. So we're left with 9a to the first. So 9a to the first divided by 4. That is our fraction. For the one on the left, we can simplify the numerator and denominator as numbers by 6 and divide by 6. That gives us 2 over 3. And now we have the variables that we can look at. We have 2 y's in the numerator, 5 y's in the denominator. So when we take 2 away from the numerator, we're left with none. When we take 2 away from the denominator, we're left with 3. So we have 2 over 3y cubed. Moving on to the next page. Go ahead, pause the video, see what you can do about simplifying these fractions. There are multiple variables here, so just treat each variable like it were a separate prime. We can't cancel x's with y's. We can't cancel y's with z's, etc. See what you can do. Pause the video and come back when you're ready to go through it. Well, in the first fraction over to the left, we can simplify numerator and denominator by dividing by 11. So we are left with actually nothing in the numerator as far as the numbers are concerned, but we're left with a 2 in the denominator. I'll write the 1 there because 11/22 is 1/2 after all. Now we don't have, let's take a look at the variables. We don't have any y's in the denominator. So that y squared actually has nothing to cancel with, and it's going to end up down here, still in the numerator, but there's nothing to change it, so it's going to stay a y squared. As far as the x's are concerned, we have 2 in the numerator, 5 in the denominator. We can cancel these 2 with 2 from the denominator and end up with an x cubed. So in the numerator we have y squared, in the denominator we have 2x cubed, so our fraction is y squared over 2x cubed. Now in the second fraction we just have 3 different types of variables, and we can just cancel them one by one. For the x's, we see 2 x's in the numerator, 5 in the denominator. Very common situation that we've seen before. We can take 2 away from each, and that leaves us with an x cubed in the denominator. For the y's, we have 3 in the numerator, which is bigger than the 2. So if we cancel those 2 in the denominator and the 1 in the numerator, we're left with 1y in the numerator, and then there's a z in the numerator and a z in the denominator, so they just cancel each other out. And then there's no z's in either the numerator or denominator, because no matter what z is, z divided by z is just 1. And so our final fraction that we're looking at is y divided by x cubed. And that's the fraction that we're left with. And last page of practice problems, go ahead, pause the video, and see what you can do about simplifying 24x to the fourth over 28y squared and 11x squared y over 18g to the fifth. Well, for the fraction on the left, we can simplify both 24 and 28 by 4, so let's divide it by 4. And then we have 6 over 7. As far as the variables are concerned, x to the fourth, those are the only x's, so that stays in the numerator. And y to the second, those are the only y's, so that stays in the denominator. And so we're just left with 6x to the fourth over 7y squared. And that's our simplified fraction. Nothing else that we can cancel. And then, actually, for the fraction to the right, 11 and 18, there's already nothing there that we can cancel with the numbers. There are no other x's, there's only one y, and there are no other g's, so there is nothing common to the numerator and denominator. This, as crazy as it looks with a monomial in both numerator and denominator, is actually the simplest version of this fraction that we can come up with. This is in simplest form. So one more time just to review, when we're simplifying fractions with variables, it's very much like simplifying fractions without variables. First we would simplify the numbers as we would if there were no variables around, and then we just look at the numerator and denominator, and any variables that we see that are common we can cancel, because whatever x stands for in the numerator, it stands for the same thing in the denominator. So if there are 3 in the numerator and 3 in the denominator, we can cancel those out because they will divide to 1.